Hey everyone, happy Friday. So here we are with, we're going to finish up section 9 for today, which is solving quadratic equations by completing the square. This first example, we basically just want to figure out what's the minimum value. The first thing I want you guys to be able to notice and identify, notice how there's two variables going on here, okay? That's actually really, really important just for recognizing purposes. The other thing, let's think about the shape of this parabola that we've got going on here. If it's a minimum, which way is this parabola opening up? Right? So there's our coordinate graph. If there's a minimum, remember, that graph is facing up. So this is positive. Now, how do we find this minimum value? The first thing that we're going to want to do, remember, our whole topic right now is to use completing the square. This right here is not going to be factored into that trinomial. So let's start by adding 1 over to the other side. Okay, now on this right-hand side, we're going to do the completing the square process. So we're going to take 4 divided by 2, and then we're going to square it. So 2 squared, so still that ends up being 4. And we're going to add that 4. Remember, when you add it to one side, you have to add it to the other. So you've got to add 4 to both sides. Okay, so now we're in the form of y equals, that should be y plus 5 equals x squared plus 4x plus 4. All right, then now we can take this trinomial and change it into a binomial squared. So this is going to turn into x plus 2 squared equals y plus 5. And then again, we want to get this y all by itself. So we're going to subtract 5 over to the other side. Look at what form we're in now. This is in our vertex form. That minimum, remember to find our vertex, that's hk. That's going to be at -2, -5. That's your minimum. All right. So then let's move over to the next example. And on this one, we're going to try and find the maximum value. Okay, so again, if we kind of start thinking about that, maximum means that our parabola is opening downward. So the first thing we're going to want to do here, you guys, kind of along the same process, let's get that 7 over to the other side because 7, first off, is not a perfect square. So you've got y minus 7 equals -x squared plus 2x. Okay, now let's do the completing the square process. B divided by 2 squared. So that's going to turn into 1. So let's add 1 to both sides. So that's y minus 6. Oh, whoops. Hang on a second. Hang on a second. Okay, let me back up just a second, you guys. One thing that we want to take care of first, so this stuff over here isn't going to change, but what they do want us to do first is they want us to take a negative out here. So that would be x squared minus 2x. And then we're still going to add this 1 over here. But since it's technically a -1, because you've got this negative out front here, what you're going to add over to the other side is you are going to subtract 1. Okay, so this is actually y minus 8 equals negative, and then that's going to be x squared minus 2x plus 1. And then from here, we have y minus 8. We can change this now into that binomial squared. So that would be x minus 1 squared. Let's add that 8 over. So I've got y equals negative. That's x minus 1 squared plus 8. So now our maximum is at 1, 8. And there it is. Alrighty. Next example. Actually, okay, so I want you guys to take a couple seconds, do 7, 8, and 9. They're along the same lines. 7 is really similar to the last example that I just did. And 8 and 9 are similar to the first one. Okay. For this one, which of the functions could be represented by the graph? Let's think about this, ladies and gentlemen. Let's look at some of these characteristics. First off, this graph is opening down. Okay, which means that our a value needs to be negative. Well, if I look at f of x equals negative 1/2 plus 4 squared plus 8. So if I'm looking strictly at the a value, f of x is still game. Same thing with g of x. You've got a negative a value, but m of x, that one is all of a sudden out because it's not negative. Okay? The other thing that we want to look at, where is this crossing the x-axis? So we've got two positive x-intercepts, right? We could say like, so x is positive, which may mean that you might need like x minus something, and set that equal to 0. Okay. All right, so if I'm kind of looking, p of x is still in the mix because that's really the only one that's in our intercept form. Let's take a look at our vertex. Our vertex right now, you guys, that should be a positive x-axis, or a positive x and a positive y. If we look at f of x and g of x, right here the vertex is 5, 9. And right here, the vertex is -4 and 8. So that kind of throws f of x out of the mix now because all of a sudden you've got a negative x coordinate and we need our x coordinate to be positive. So when you kind of look at this, you guys, either g or p of x would work. Okay, so this is just a really good problem that tries to get you to interpret all of the different characteristics of your graph. Alrighty, last example. We've got the function y equals -16x squared plus 96x represents the height of a model rocket x seconds after it is launched. Find the maximum height of the rocket. Okay, well before we were trying to find a maximum, just the same concept. First thing that I suggest that we do here, ladies and gentlemen, is let's, after I finish writing this down, let's first, I have a factor of 16 in here. Let's get that out of there. So this is x squared minus, let's see, that should be 6. And that equals y. Now let's do the completing the square process, because if you're trying to do completing the square process with a 96, that gets really big. Let's use this 6. So 6 divided by 2 squared would turn into 9. So let's add 9 to both sides. Okay, so this is negative 16x squared minus 6x plus 9. Okay, now when we were finding the maximum before, remember how there was that negative out front there? What you have to do to the other side is you have to add in the factor of negative 16 times 9. Because you've got this factor of negative 16 out here. Remember, this 16 can be distributed out. We have to keep this balanced. Okay? So actually on the right-hand side, that's going to turn out to be y minus 144. And then that's going to be negative 16. Just for the sake of the problem, let's just rewrite this. So again, negative 16 times 9. We took that out, and now, so up here when we were completing the square, we did the 6 divided by 2. If we would have done the 96 divided by 2, that would have been the number that we added over to the other side. Since we took that out, we got to add it back in when we're multiplying on the other side. Okay, so now I've got y minus 144 equals negative 16. This is going to turn out to be x minus 3 squared. Then we can get the 144 back over to the other side, negative 16, x minus 3 squared plus 144. Okay, so now they want to know what is the maximum height of the rocket. So if we kind of think about this, our x coordinate is 3, our y coordinate is 144. If we think just on this xy axis here, height, remember, is our y coordinate. So the height would be 144 feet. Then part B asks us, find and interpret the axis of symmetry. Okay, now this requires us to think back to last week, or a couple weeks ago, when we were talking about vertex form. Remember, with the vertex form, x is just your h coordinate, so that's this right here. So your axis of symmetry is just going to be 3. And then they just want you to be able to understand that, like, until this rocket hits this point here, again, your function is increasing, increasing, increasing until it hits that axis of symmetry. Then it starts decreasing, decreasing, decreasing. Okay, so that's what the axis of symmetry is it's that turning point from where your graph goes to increasing to where your graph goes to decreasing. All right, I am all done. Enjoy your weekend. Make sure that you get all of these notes taken down. If you want to finish up the assignment, go right ahead. You do not have to, though. I know it's supposed to be a nice weekend. So as long as you get the notes written down, we can take care of the assignment on Monday. Have a great weekend, you guys. I'll see you then.